We are looking at polynomial function. But before we continue, kindly subscribe to the channel and share it to colleagues and friends so that anytime I post lessons of this nature, you can have access to them. A polynomial function comprises of various combinations of constants, variables, and exponents. The general form of a polynomial function can be given as this, where a, b, c, d, etc. are constants and n is a non-negative integer. N must be a non-negative integer. So the general form of a polynomial function is of this nature. Now let's take note of this. Polynomial is named by its highest degree or exponent. So the name of any polynomial is determined by the highest degree of it. So let's look at some types and their general form and examples. So we can have a constant polynomial. So a constant polynomial, there is a general form. A typical example is this: if we have y equal to 2, it's a polynomial, it's a constant polynomial. Y equal to negative 4 is an example of a constant polynomial. Likewise this. So anytime you have the value y equal to any value, where k can be any number, then we said it's a constant polynomial. We can also have linear polynomial. Linear polynomial is of this nature. It's having the independent variable, which is our x, is having a degree of 1. So a cannot be 0, because when a is 0, you will not have this. So this is a general form of linear polynomial. So linear polynomial can be like this. This is a specific example. Likewise this. So equation of a line. If you have come across equation of a line, all equation of lines are examples of linear polynomials. So these are examples of linear polynomials. Then we can also have quadratic polynomials. So a quadratic polynomial has a degree of 2, highest degree of 2. And take note, a cannot be 0, because if a is 0, you will not have this. It will be reduced to linear. So a shouldn't be 0. Now we can have a specific examples like this. This is a quadratic polynomial. Once you always look at the degree. So once the degree is 2, the highest degree is 2, then it's a quadratic polynomial. Then we can also have cubic polynomial. So by the name cubic, it means the highest degree is 3. So this is general form of a cubic polynomial. These are specific examples. So these are cubic examples of cubic polynomials. The highest degree there must be 3. Then we can have quartic polynomial. Quartic polynomial. Quartic polynomial has a highest degree of 4. So if you have a polynomial with a degree of 4, then we said it's quartic polynomial. So these are examples. The highest degree there is 4. So these are examples of quartic polynomial. We also have quintic polynomial, which has a highest degree of 5. The highest degree is 5. So an example is this, and this. These are all examples of quintic polynomials. We can perform all operations on polynomials. We can subtract polynomials. We can add polynomials. We can divide polynomials, and then we can multiply polynomials. In this lesson, we will look at the subtraction, the addition, and the division. The multiplication of polynomials will be done in another lesson. So we are going to try the questions above. So we are to subtract g of x from h of x. So this is how you have to start it. We have h of x minus g of x. Now we subtract like terms. So 5x cubed, its like term is 2x cubed. 2x squared has no like term here. X has a like term of 5x, and 5 has a like term of 7. So let's see how we can do our subtraction. So we are going to have 5x cubed minus 2x cubed. To simplify, to make it simple, just be putting them into brackets. Plus 2x squared has no like term. So you make it minus 0x squared. X has like term of 5x. 5 minus 7. So you could see that this minus sign is affecting this element in these brackets in that order. So you are going to have 5x cubed minus 2x cubed. This means you are finding difference in x cubed. This is going to give us 3x squared x cubed. This is going to give us 3x cubed, then plus 2x squared minus 4x and minus 2. So h of x minus g of x will give us this as our final answer. In subtracting, this is just very simple. We don't do anything with the degree. We subtract coefficients and then maintain the degree of the variable. So 5 minus 2, 3. What are we subtracting? We are subtracting s cubed. So you bring it. So see this, the s cubed as a unit. Just see it as a unit. All of them, just see the x as a unit. This one has a coefficient of 1. So 1 minus 5 minus 4. Just see x as a unit, so you bring your units attached to it in that order. So we have to find h of x plus g of x. To do this, we group like terms. So the like terms, we look at the exponents of the variables. So this has a like term of this. This has no like term over here. X has a like, so you group your like terms and then you add them accordingly. So it's 5 plus 2, 7. Then you add s cubed to it. That's, you see it as your units. So x cubed. There is 0. So we still have 2s squared. X has a coefficient of 1. So 1 plus 5, 6. Add your units to it. See this one as your units. So add it. 6x plus 5 plus 7, 12. After that, you take them from the brackets. So you have 7s cubed plus 2s squared plus 6x plus 12. This is the final answer. Like I said earlier on, we can divide polynomials. So let's look at how to divide. Now, anytime you are dividing polynomial functions, there are parts that we need to know. We call this the numerator the dividend. That's what we are going to divide. Then the denominator, we call it divisor. The result that we will get will be called quotients. So in division, we have our dividend, then we have our divisor, then the results will be quotients. Let's look at the positions of these parts into our long division. So in this case, the divisor will be outside here, our dividend will be inside here, then our quotients will be found over here. So in our first example, this is how the arrangements will be. This is our divisor and this is our dividend. So to divide, you pick the divisor, then you divide it by the dividend. So this is how it's done. X will go into x exponent 4 as x cubed. Take notes. We have x exponent 4 divided by x. by indices rule, you have x exponent 4 minus 1, which will give us x exponent 3. Then you multiply this, your results here, by the linear function over here. So x exponent 3 times x will give us x exponent 4. X exponent 3 times minus 2 x exponent 3. Then you subtract this from this. So this and this will give us 0. We are going to have x exponent 3 minus 2x exponent 3, which will give us x exponent 3. Then you bring the rest of the terms down here. So you have minus 11x squared minus 5x plus 30. You repeat the same process. X will go into 3x exponent 3 as plus 3x squared. Again, you multiply this by the polynomial here, that's by the divisor. So you have 3x exponent 3, then minus 6x exponent 2. Again, you subtract. This and this will go 0. We have minus 11 minus 11 minus minus. So you have minus 11x squared plus 6x squared, which will result to minus 5x squared. Then you bring the other terms to come and add. And again, the x will divide this, which will give us minus 5x. You multiply the term by the divisor. So you have minus 5x squared. Let's say minus 5x times 2, minus 2, which will give us plus 10x. You subtract again, this will give us 0. We are having minus 5x minus 10x, which will give us minus 15x. Then you bring your term, the last term, which is 30, the constants. Then x will go into minus 15x as minus 15. You multiply again, so you have minus, that's minus 15 times x, will give us minus 15x. Minus 15 times negative 2, that's plus 30. You subtract again. This will give us 0, and this will give us 0. So when we divide x exponent 4 plus x cubed minus 11x squared minus 5x plus 30, when you divide it by x minus 2, our results will be x cubed plus 3x squared minus 5x minus 15. This will be our results. So I'll leave the second example, second question for you to try and put your results in the comment section.